Hello everyone, we are representing Group 4 from Tamara Siksa School. Today I want to talk to you about a phenomenon that affects all of us living in the cities, the urban heat islands, hotspot in Thailand. Have you ever noticed that when you come into the city from the countryside, it suddenly feels like you have stepped into an oven? That isn't just your imaginations, it's called the urban heat island effect. Essentially, our urban areas can be 2 to 4 degrees Celsius warmer than the surrounding rural areas. Why does this happen? It's simple physics. We have replaced comfortable natural surface, like grass and tea, with heat-trapping material like concrete, asphalt, and metal. This artificial surface trap heat during the day and refuse let it go. For our research, we had 3 main goals. So the first one, we identified 6 specific land cover types right here in Nakhon Si Thammarat to compare their surface temperatures. Second, we studied how this surface hold onto heat by tracking temperature shift from 2 p.m. into the evening. And finally, we want to see how our home province compared to others. So we looked at data from Sraburi, Suphanburi, and Tam as well.
To get the accurate data, we didn't just get. We used the infrared thermometer, curved land cover observation tool, and even drone imagery verified our surface type. We followed a strict protocol, taking measurement at 50 centimeters above the ground and averaging 3 readings per point to ensure our number were solid. We mapped out our study area, including locations like Wolayalak University, focused on 6 specific surfaces: concrete, dry land, asphalt, water, glass, and metal. So here is about the data analysis method. The following analyses were performed: descriptive statistics for all surface types, and one way and what to test temperature difference. So we use software and tools such as Google Earth, Google Map for spatial mapping, Google Sheet for data managing and ANOVA, and Globe and NASA appearance. Moving on to our result, the numbers tell a clear story. During the daytime, metal was the hottest surface, reaching a scorching 38.1 degrees Celsius. However, looking at nighttime data is crucial. At night, concrete becomes the warmest surface at 30.7 degrees Celsius, while natural gas cooled down to 22.8 degrees Celsius. Our ANOVA test confirmed that these temperature differences are statistically significant, not just random chance. The graph visualizes those numbers. You can clearly see the yellow bar represent concrete, remaining high even as the sun goes down. This visually demonstrates the heat retention capacity of our road and building compared to the blue and green bar of natural surface, which drops significantly in temperature. So here is about heat retention pattern in Nakhon Si Thammarat. You can clearly see as the information that given in the picture. We then expand our scope to compare Nakhon Si Thammarat to other provinces. This chart compares the average land surface temperature across the different locations. You can see the blue bar for daytime and the red bar for nighttime. This comparison helps us understand if the heat trend we see locally are consistent across different parts of Thailand. This result, we established a thermal hierarchy. Metal and concrete are undeniable that the hottest surface during the day, peaking over 31 degrees. However, we found out that Nakhon Si Thammarat actually exhibited a mild urban heat island effect compared to others. This is likely due to our coastal geography, frequently rain and upland vegetation, which help break the heat. Satellite application identifying urban hotspots help inform heat-sensitive urban planning and support design of building and space to reduce heat. Urban heat island data in Nakhon Si Thammarat help identify high-temperature area and support heat-sensitive urban planning. It improved building and public space design by promoting shading. Based on our findings, we focus on 3 key areas for the future. First, sustainable development. We must expand green space to improve public well-being. Second, climate resilient. Design city that can adapt to heat wave and extreme event. And third, smart city technology, using data system to manage energy efficient better. It is important to weigh the impact of this loop. Negatively higher urban temperature lead to increased electricity used for the air conditioning and higher risk of heat stress for the resident. However, there are some functional advantages to heat retaining surface, such as road drive faster after heavily rain and supporting activity city life into the evening. In conclusion, our study confirmed that material will build our city with directly dictate our local climate. By understanding which surface trap the most heat, we can make smarter decisions for urban planning in Nakhon Si Thammarat. This project was a collective effort by all members of Group 4. We would like to give our special gratitude to Glove expert, Associate Professor Dr. Krishnadeb Charan Suthasini, Associate Professor Dr. Malika Charan Suthasini, Mr. Tony, and Mr. Thiradet Onmek, who helped us during this research. Thank you.